polymers could be called incredible modern materials. You know, I think in chemistry we don't do a good enough job of just explaining how marvelous some of these materials are that we've made. You know, and they get a bad reputation. They think they're all bad for you, but you know, many of these chemicals that we're talking about come from naturally occurring materials as well. Actually, all of them have to come in some way from a naturally occurring material. When we talk about polymers and the amazing modern materials that they are and the amazing modern properties that they give us that simply would not be possible without polymers. You know, contact lenses, bulletproof vests, artificial joints, power for satellites, diapers, you know, all right, so maybe I'm stretching the point there a little. The point is, you couldn't have those kinds of materials or those kinds of properties with non-polymeric materials, because by the time you get to very large materials, you change the physical properties dramatically, and you see things that you don't see otherwise. Now, with all of those incredible polymers, both natural, the DNA in our bodies, an incredible polymer, modern material, if you will, with all of those, let's face it, there's one polymer that has excited more students all over the country and probably all over the world to the excitement of polymers, and that polymer is, of course, slime. Everybody's made it. So what we're going to do is make it and add a little twist to it because everybody's made it. Now, the slime can be made with, it's always got borate ion as a cross-linking agent. The polymer that you start with can either be the polymer in glue, white glue, which is polyvinyl alcohol, or you can use a natural polyalcohol, which comes from seeds, and that's called guar gum. And guar gum is harvested and extracted and purified for use as a food additive. It's a thickening agent. So I have pre-weighed here about 1 gram of guar gum. You can see it's a pale yellow powder. In my beaker, I have 100 milliliters of basically a water solution that has 2 dyes or indicator dyes in it. One of them is fluorescein. Of course, fluorescein is well known as the fluorescent dye, so that's going to give our polymer its twist. And the other dye is bromphenyl blue, which is an acid-base indicator. And right now, that's kind of a greenish-looking solution. Doesn't appear totally transparent. And I'm simply going to add I'm going to try to do this, tap it in and stir. Because what I want to do is mix and stir. And as you're doing that, you kind of see that the color that you're looking at, depending on the angle that you're looking at it, appears quite different. So I'm going to add that and so far not so much. It's, you know, it doesn't appear a little bit thicker perhaps, not much. And that seems to be pretty well mixed. And I had about 1 gram of that. And the nice thing about making slime, of course, is, you know, the ingredients, the amounts are not crucial. And now to that dispersion of the guar gum in the indicator solution, I'm going to add my borate ion, which comes from borax. And I've got 5 milliliters of a 4% sodium borate solution. And I'm going to add that slowly. And as I add that, you should begin to see, I can feel it. I don't know whether you can see it yet. Probably if I lift that out, you can see it. And I've added that. And I think you can see now that I'm not really stirring a solution anymore. I'm stirring slime. Ah, yes, kids love it. And I guess if that works, then that works. And what you would do at this stage with the slime, when it gets the desired consistency, is you would add that to something like a plastic bag. So we'll go ahead and do that really quickly here, just so you can kind of see us kneading it. I knead this polymer. I'm going to add that to a large bag, simply dump it in. Boy, clean cup too, you know what, it all comes out. All right, we got our slime in there, and we're just going to knead that a little bit, just like you would, until it kind of comes together to a more uniform consistency. Right now it's got a kind of a little bit still of a grainy consistency, but eventually that would give you a nice homogeneous looking material. And as with all good cooking shows, right, We made one ahead of time, and that one is done. I like that. Okay. Now, we said this was going to be slime with a twist. And the twist has to do with the presence of those indicators in it. Now, if I put this on this box and we bring the lights down a little bit, right, or we said to about dusk or a little bit more, what we should see is that the color of that slime looks red to me, totally. I've got it on this white background, and so I've got a little bit of light coming through. And if I'm looking straight down at the light that's passed through that slime in there, it looks totally red to me. Okay, it looks red to everybody. I'm happy to hear that. So what are we looking at there? We're looking again at the nature of color. Light can do many things with materials. Light can be absorbed, it can be transmitted, and it can be reflected. But we can also have fluorescence. So what we were looking at there with the red color was the color of the transmitted light. Okay? It was absorbing the complementary colors. The color that we were seeing was red. We added some fluorescein, though, and so we want to take the lights back down, and I have a black light here. I'm going to turn on my black light as soon as you guys are ready, and we're going to go pretty dark there, and I see, depending on the angle there, I see a really bright green fluorescence there. So that's our slime with a twist. So it's red in transmitted light. It's, of course, the bright green in the fluorescent black light, which is the fluorescent color. But there's one more thing in this. Oh, you know what? I'm not sure I totally understand it, but we talked about light can do three things. It can be transmitted, it can be absorbed, or it can be reflected. So what's the reflected color of this? Well, in order to see the reflected color, I need to put it on a dark background. So I'm going to go ahead and put this right on the table there in front of that. And do we see that the reflected color, so I have no light coming through from the bottom, now what it looks like is simply a dark green. It doesn't look red if you have any light at all bouncing off, but otherwise it looks green. And so with slime, a very, very popular material that all of your students have already seen, you can talk about, guar gum, you can talk about where it comes from. It's a naturally occurring, it's a carbohydrate polymer. It's basically an indigestible, is that the right word? Indigestible fiber material. It's used as thickening agents and so on. This is a way to tie together some consumer chemistry, guar gum with its uses, with slime and the properties of materials. Basically what you're getting here is cross-linking with that borate ion, which has 4 OH minus groups attached to the central boron, and all of those OH groups on neighboring carbon atoms in that guar gum, which is a carbohydrate polymer. And you're getting cross-linking. When you draw a picture of cross-linking, it looks two-dimensional. But the reason that you get this slimy material, basically, or slimy consistency, which is somewhere between a solid and a liquid, the reason that you get that is because you're forming a three-dimensional network in which you have all of these very large, I'm going to put that down and I'll use my hands because if I didn't have my hands, I couldn't explain polymer chemistry. All right, so you've got all of these really long chains, which is just your guar gum, your naturally occurring carbohydrate polymer. And that's got all these OH groups on the same chain and, of course, on all of the other chains. And the important thing in terms of the cross-linking and getting this gel-like or slimy consistency is that a single borate ion with its 4 OH minus groups will tie together many different chains, okay, in an infinite three-dimensional network. Essentially, if you calculated the composition of slime, it would be like 96% water. There's very little of the other stuff in there, but what you're doing is you're trapping the water in that network. It's as if with borate ion and the guar gum forms a lattice in 3 dimensions, and you have to imagine that. And then the water gets incorporated into that lattice network, and that's what makes what's called a gel or a slime or whatever. Slime with a twist, an incredible modern material? Well, you tell me. Thank you.